just like a review question. So actually it's very similar to the last couple problems on the homework, if you guys remember. I'm going to get rid of any addition or subtraction just real quick first. So I'm going to add 12, and I'm actually just going to come over here. So I have 4 times x plus 3 squared. Oh, what is that? 400. Okay, what would you do next? You're solving this equation.
Divide everything by 4.
Yes, don't distribute, divide. Don't distribute, divide. So we're going to divide everybody by 4. Now, on the left side, all that's going to give you is that x plus 3 squared, and then on the right side, literally just 400 divided by 4 would give you 100. Okay. Now, we're not dealing with imaginary numbers here because that's not negative, so this will be kind of a little throwback to what we did a couple days ago with square roots. But how would I keep going here? What do you think? Square root. All right. Do not FOIL. You're just going to, you can, but it's just going to be a lot of extra work. So don't FOIL. You can just cancel the parentheses right out right there. That's awesome. You just can't forget to put the plus and minus in front of whatever you take the square root of. Now, square root of 100, it's a perfect square. So this is just 10, but it would be 10 or negative 10 with that plus minus symbol. Okay, now one more step. I got to move the 3, so I got to subtract it. And so I just would tell you, literally just put the negative 3 right after the equal sign, then plus or minus 10. Now, yesterday we got stuff like this. It had an I, it had a radical, whatever. You can take negative 3 and add 10. And you can take negative 3 and subtract 10. So on this kind of a question, go ahead, don't leave it like this because you can simplify this. Like negative 3 plus 10 would be 7. And if I did negative 3 minus 10, that would be negative 13. Forgive. I have a feeling I'm going to do a little tiny review with you guys. These two questions both represent what we call a perfect square trinomial. And so I'm going to ask you if you can tell me the factors, the factored form of these just real quick. And then I'll tell you what it means because I think it'll make more sense. So I don't have a number in front of the x squared. I just need to know, so I'm going to multiply a times c and add to b to do any kind of factoring. But in this case, the a value is just 1. So tell me 2 numbers. Just up and by, go ahead, take it back to her. She wasn't supposed to give that to you. Sorry, we just had a big phone conversation about it. I'm so sorry. I know that's a long walk. Thank you, ma'am. All right, so we're going to multiply to get 25, add to get 10. Okay, now, I know my factored form, I'm going to write up here, has to just start with x and x, because if I multiply that back, that'll give me the x squared. What 2 numbers multiply to give you 25, add to give you 10? 5 and 5. Okay, now, here's the deal with these. A perfect square trinomial, both of the factors are exactly the same. So, that allows me to write this as x plus 5 squared. All right, now, if you guys notice, like the question we just did, we had that set of parentheses with the x minus 3 squared, and we were allowed to cancel that out by taking the square root. So this is going to be the goal today, to create like a set of parentheses like this. So let's try this one. So this one's just a hair different. So this is multiply a times c again. So 1 times 49, and I got to add to get the b value, which for this question is negative 14. Can you guys think of 2 numbers, if you multiply them, you get positive 49, but you add them, you get negative 14. Negative 7, negative 7. Okay, both of these multiply to get you positive, but add to get you negative. So they have to be in one of these formats to do this. So it's either got to be a plus plus or a minus plus. If it's a plus plus, this will be positive. If it's a minus plus, these guys again, these are the same. It'll just look like this, x minus 7 squared. But it's still something I can squish them together because both factors are the same. So that's what a perfect square trinomial is, if you want to write that down. Both factors are the same. Both factors are the same. Okay, now, not every question that we get is in that format. So what we're going to talk about today is how to create that for ourselves. And I got to tell you guys, I'm not going to have you guys do this with an a value that's not 1 because it's so much extra work, and there's other ways you can use to solve a quadratic than completing the square. You can use it on any question, but I'm not going to give you guys anything where the a value is not equal to 1. So This is literally all you have to do. The plain number, to make this happen, to make both factors the same, needs to be whatever the b value is, divided by 2, and squared. Call that the magic number that'll complete your perfect square trinomial. We're just going to practice this in this example underneath here. But you just got to tell me the number in front of the x. We're going to divide that number by 2, and we're going to square it. And I'm going to show you a little cheat with how to find the factors if it gets tricky. So I'm going to complete the perfect square trinomial. So what I'm going to use is this little formula right here, right above. I'm just giving us some space so I can write down what we're going to do. So I got to grab the b value. So for this one, be 20. I'm going to divide that by 2, and I'm going to square it. All right, 20 divided by 2 is 10, right? And what do you get if you square 10? 100. So 100 is what is going to be the number I need that plain constant term to be. Okay, now, see if you can tell me this. Tell me two numbers that multiply to give you 100 and add to give you 20. 10 and 10, right? This would be x plus 10, x plus 10, right? So this we could write as x plus 10 squared since both of the factors are exactly the same. Okay, now I'm just going to back up just a teeny bit and show you this. I promise you, if you do this correctly, whatever you square, like we squared 10 to get that magic number, that will match the number that is in your factor. And you're probably like, well, I could have figured that out, but I'm going to show you why that's a little bit of a good trick to know on one of the questions here. Okay, now, the second problem says x squared minus 8x, and we're going to complete the square, so I'm going to add a number here. And it's always positive because when you find that number, it's the b value divided by 2 squared. Whenever you square something, it always makes it positive. So here your b value is actually negative 8. I'm going to divide that by 2, and I'm going to square that. So negative 8 divided by 2, right? That's negative 4. We're going to square that. What's negative 4 squared?
I, 4i.
That would be the square root. That would be the square root. But what if I take negative 4 and I square it? So negative 4 times negative 4. 16. Okay, you did the square root. I said it. I probably said it wrong. So 16. Okay, now tell me two numbers. When you multiply them, you get 16. But the same two numbers, you add them, and it gives you negative 8. Negative 4 and negative 4. Or we could just write, since they're the same, we can squish them together, write it as x minus 4 squared. Now, this is another one I'm going to show you. Look, whatever you square, in this case, we squared negative 4. So then in my factor, it was x minus 4. Whatever you square, that's going to be what's in the factor whenever you do these problems. Okay. Now, I'm going to have you do this on this, but I'm going to tell you this is weird. So this last one, unfortunately, and this is where this can be a tricky method to choose to solve a quadratic, my b value is not an even number like it was on these previous two questions. So I'm going to do the same thing. It's the b value, which is negative 3 here, divided by 2, and we're going to square that. Okay, now, I can't actually divide negative, like that's as simplified as that fraction gets. I can square it, though. So if I square it, what you do negative 3 squared over 2 squared. So we're just going to square the top and the bottom. The negative is going to cancel out, because if I do negative 3 times negative 3, that is positive 9, and the bottom of that fraction would be 2 squared, which is 4. And you're like, Miss Grody, I do not want to deal with this. And I can get that. I can get that from this. If that b value is odd, I don't tend to choose completing the square as a method, but I will show you. You can write this in the factor, and I promised you on the other two questions. Whatever you square is the factor. And I know this is weird, but this would be like multiply to get 9 over 4 and add to get negative 3. I swear to you, it's whatever you squared. So this would be x minus 3 over 2 squared. It matches whatever you square. If you actually FOILed this out, which I'm not going to do because I don't want to mess around with the fraction, so don't worry about it too much, but whatever you squared, that goes in the factor with the x. Is anybody having a question? Okay, now I'm going to have you do on the back, and there's a big long drawn out thing that tells you how to do this at the top, which I'm not going to read to you, but you can go back if you want to. This is the process. And this, I'm just going to explain it to you with the problems as we go through here. Okay, this says solve by completing the square. So here's what I'm going to do. I'm going to write x squared plus 8x, and then I'm going to make a space to complete the square, just like we did on the other side. Now, what happens if you use this in an equation is now I have an equal sign. I didn't have that in the other problems we were practicing on the other side just to complete the square. Whatever I do to one side of the equation, I have to do to the other. So I'm going to complete the square on the left side, but to do that, I'm going to add some number there. So I have to add that number to the other side of the equation as well to keep my equation balanced. So you just got to remember to do that. Whatever you add, you're going to do it to both sides. So I'm going to take my b value. My b value is 8. I'm going to divide that by 2 and square it. So that's 4 squared, which is going to be 16. I'm going to add it to this side. That'll give me a perfect square trinomial. That'll give me the thing where the two factors are the same. But because I added that to that side of the equation, I have to add that same number over here to the other side. Okay, super quick. If you want to skip this step, go ahead. Factored form of this, multiply to get 16, add to get 8, is x plus 4 times x plus 4. 20 and 16 literally just add, that's 36. Now if you guys remember, the two factors should be the same, which they are, so I can squish it together, write it as that x plus 4 squared. Okay, remember I promised you, whatever you square, that's what goes in your factor. Now this turns into super easy to solve because I can just take the square root here and get rid of the parentheses. That's the whole reason for doing this. You want the two factors to be the same, then we can squish them together, and then we can get rid of the parentheses just by taking the square root. So this becomes x plus 4. Now the other side, anybody know square root of 36? 6. Just don't forget your plus and minus. I got to move the 4 to the other side, so I get negative 4 plus or minus 6. So we can actually I don't have a radical, I don't have an I, so we can actually add this. So negative 4 plus 6 would be 2, and then negative 4 minus 6 would be negative 10. Those are my two answers. It's a little bit weird, but it's not bad to do once you set it up. It's just a matter of finding that number you're going to add to both sides. Okay. Now, I'm going to have you do one problem like this. I'm not going to lie to you, this is going to be harder because the b value is an odd number. All right? But I'm going to set this up the same way. I'm going to say x squared minus 9x plus, I'm going to leave a space to complete the square. Whatever I do to the right side of the equation, and whatever I do to the left, I have to do to the right. So I have to add that number on both sides of the equation. So here's what I'm going to do. I'm going to take my b value, and I'm not going to lie to you, we're going to use fractions on this. My b value is negative 9 divided by 2. We're going to square that. Okay, can't simplify it. So this is what I'm going to square. When I do that, I'm going to get positive 81 over 4. So I'm going to have 81 over 4, 81 over 4. Now, the left side, this is not bad because I promise you, whatever you squared, that's going to go in the factor with the x. So whatever you squared, this is negative 9 over 2. I'm going to write x minus 9 over 2 squared. That would be the factored form of that. Whatever you square, that's your factor. Okay, now on the other side, this is a little bit annoying, but I'm just going to grab my calculator here. I'm going to do negative 19 plus, if you guys have a scientific calculator, just use your fraction key. I don't have a fraction key on here, so I'm going to do 81 over 4. And then I don't want to leave a decimal, and I'm going to show you why in a second. I'm going to convert this to a fraction. And if you need help doing that on the calculator, what I'm doing on the graphing calculator, if you have that, just where you can't see my finger, the math button right here, and you're just going to hit enter twice, and it'll convert it to a fraction. This is 5 over 4. Okay, now, I know initially that doesn't look great, but it's not bad. Leave it in a fraction, and I'm going to show you why. The bottom of that fraction will always be 4. And 4 is the perfect square. So I'm going to show you this. This would become x minus 9 over 2, plus or minus. Okay, now, 5 under a square root does not break down, but 4 under a square root is actually 2. And I know this looks a little garbagey, but you can actually add this 9 over 2 to the other side. So 9 over 2. Alright, so I got 9 over 2 plus or minus square root of 5 over 2. Both of those guys are over 2, and that'll be the case anytime you do this with the completing the square. So you can actually write it like this: 9 plus or minus the square root of 5, the whole thing over 2. And that's actually, I know that's a little complicated, but those are my 2 answers there. Is anybody having a question? That's the only one I'm going to have. I think I have one on the homework for you to try with the fraction. But you want to use the fractions because you're going to be able to take the square root of 4 on any of those problems. That becomes 2. And then the other side will have a 2 in the denominator, so they'll always have a common denominator. You won't have to create that. Okay, I'm going to have you guys do these 2 at the bottom. These 2 are going to have imaginary solutions, but it's the same setup. I'm going to do x squared plus 12x. I'm going to leave a spot to complete the square. The other side of that equation was negative 40, but I know I'm going to complete the square, so I got to leave myself a space on the other side to add whatever that number is to both sides of the equation. All right, for this guy, the b value is just whatever's in front of your x, so this is just 12. So I'm going to do 12 divided by 2. I'm going to square that, which is going to give me 6 squared, which is going to be 36. Okay, I swear to you, if you did this right, the b value divided by 2 squared, whatever you ended up squaring, which was 6, that'll be your factor. So multiply to get 36, add to get 12, 6 times 6, 6 plus 6, I'm just going to write x plus 6 squared. It matches whatever you squared. The other side of this is just negative 40 plus 36, which will give me negative 4. Now, we're going to take a square root, but now we know how to do the square root of a negative number from yesterday. So I get x plus 6 here. Square root and squared cancel each other out. Do not forget the plus minus in front of your lovely radical. Anybody know square root of negative 4? 2i because of the negative. So this is plus or minus 2i. You got to do one tiny thing. We just got to move the 6. It's positive, so to move it to the other side, I'd have to subtract it. We're not actually going to go any farther than this, though, because I just write negative 6 right after the equal sign, plus or minus 2i. I can't keep going because I can't add that real number to that 2i. I can't combine those. They're not like terms. So these are your 2 answers. They're just going to be imaginary. Okay, I'm going to have one left. I'm trying to finish this before we've got a little short class today. So I'm going to do x squared minus 4x. I'm going to leave a space to complete the square. On the other side, I got negative 36, and I know I'm going to complete the square on the left side, so I got to leave a space to complete the square on the left side and then add that same number to the right to keep my equation balanced. Okay, for this guy, you're grabbing your b value. This is negative 4, so it would be the b value, negative 4, divided by 2 squared. That's going to give you negative 2 squared. Everything you square always becomes positive. That's why I keep writing a little plus with the in front of these blanks. It's always positive, so this would be a 4 and a 4. All right, now, on your left side, whatever you square, I swear that's your factor, if you did it right. So multiply to get positive 4, add to get negative 4, negative 2, or we can just write x minus 2 squared. That would be the factored form of that. The other side, negative 36 plus 4, negative 32. And unlike the previous question, that's not a perfect square. So we're going to have to break that down a little bit. But very similar to the last question. I've got x minus 2, square root and squared cancel each other out, plus or minus. I see that negative, so I'm immediately just going to pull an I out in front of that. That gets rid of the negative under the square root. And we got to break down the 32 since it's not a perfect square. So tell me 2 numbers that multiply to get you 32. 4 and 8. Okay, 4 is 2 and 2. 8 is 4 and 2. And then 4 is 2 and 2 again. So I broke down the 32, the 4, the 8, and this 4. You have a pair of 2s. Then you have another pair of 2s. And there's 1 2 that does not have a partner in that question. So when I take that factor tree to break that down, out in front with the I, you're going to have a 2 and another 2. We multiply together anything we take out. 2 times 2 is going to have a plus or minus 4i in front of this radical. And then left underneath, we just had this 1 2 that didn't have a partner, so that would be under the square root. Now, I had x minus 2 equal to that, so I got to do one more tiny thing and just move the 2, but I can't actually add that to the other side in terms of like simplifying anything else. So just put that 2 right after the equal sign, and then the plus or minus 4i radical 2. You can't actually do anything farther than that. There are going to be 2 separate pieces there, but it's actually 2 different answers because of the plus and minus symbol. Is anybody having a question? Okay, the homework should be super similar to the notes then.